Energy is everywhere. It permeates every corner of our world and beyond, from the smallest atom to the vast expanses of the cosmos. It is the invisible force that makes everything happen. Without energy, there would be no movement, no growth, no life. Energy allows us to move, grow, and even think. It is the driving force behind every action and reaction in the universe. It powers our homes, cars, and the devices we use every day. From the moment we wake up to the time we go to bed, energy is at work. Without energy, the universe would be a very different place. It would be a static and lifeless void, devoid of the dynamic processes that shape our world. It would be a static and lifeless void. Imagine a world where nothing moves, nothing changes, and nothing grows. Energy is the ability to do work. It is what allows us to perform tasks, from the simplest to the most complex. Work is done when a force causes an object to move. This can be as simple as lifting a book, or as complex as building a skyscraper. For example, when you lift a book, you are doing work against the force of gravity. This requires energy, which comes from the food you eat. You need energy to do this work. The food you consume is converted into the energy your body needs to function. Energy exists in many different forms. These include kinetic energy, potential energy, thermal energy, chemical energy, and radiant energy. Each form of energy has its own unique properties and uses. These forms of energy can be converted from one to another. For example, solar panels convert sunlight into electrical energy. For example, when you burn wood, the chemical energy stored in the wood is converted into thermal energy and light energy. This process releases heat and light, which can be used for warmth and illumination. Energy is essential for all life on Earth. Without it, ecosystems would collapse, and life as we know it would cease to exist. Plants use sunlight to produce food through photosynthesis. This process is the foundation of the food chain, providing energy for all living organisms. Animals eat plants or other animals to obtain energy. This energy is then used for growth, reproduction, and daily activities, and humans use energy to power our homes, businesses, and transportation systems. From electricity to fuel, energy is the backbone of modern civilization. Where did all this energy come from? Scientists believe that the universe began with a massive explosion called the Big Bang. This event happened about 13.8 billion years ago. In an instant, all of the matter and energy in the universe was created. At the moment of the Big Bang, the universe was incredibly hot and dense. As the universe expanded, it cooled down. This cooling allowed matter to form. The first atoms formed just a few minutes after the Big Bang. The Big Bang was the ultimate energy release. It is the source of all the energy that we see around us today. Even though the universe has been expanding and cooling for billions of years, the energy from the Big Bang is still present. Kinetic energy is the energy of motion. Anything that is moving has kinetic energy. The faster an object moves, the more kinetic energy it has. Kinetic energy depends on the mass and speed of an object. A heavier object moving at the same speed as a lighter object will have more kinetic energy. Similarly, an object moving at a higher speed will have more kinetic energy than the same object moving at a lower speed. Examples of kinetic energy are all around us. A moving car, a running child, and a flying bird are all examples of objects with kinetic energy. We harness kinetic energy in various ways. Wind turbines use the kinetic energy of wind to generate electricity. Potential energy is stored energy, waiting to be unleashed. It is the energy that an object possesses due to its position or state, and it holds the promise of motion and activity. This type of energy is often referred to as the energy of position. Imagine an object placed on a high shelf or a person holding a ball above their head. Both scenarios illustrate potential energy. Potential energy is sometimes called energy of position because it depends on the location of the object within a force field such as gravity. For instance, a book held above the ground has potential energy due to its position within Earth's gravitational field. The higher the book is, the more potential energy it has. One common type of potential energy is gravitational potential energy. This is the energy that an object has due to its height above the ground. The higher an object is, the more gravitational potential energy it possesses. Think of a hiker looking down from a mountain peak or an object held high above the ground. The concept is simple. The higher the elevation, the greater the potential energy. This principle applies to everything from tall buildings to towering trees. Another type of potential energy is elastic potential energy. This is the energy stored in objects that can be stretched or compressed. For example, when you stretch a rubber band or compress a spring, you are storing elastic potential energy in those objects. A stretched rubber band is a perfect example of elastic potential energy. The energy is stored in the tension of the stretched material. Potential energy can be converted into kinetic energy, which is the energy of motion. This transformation is a fundamental concept in physics. For example, when you drop a book, its potential energy is converted into kinetic energy as it falls. The same principle applies to a rock falling off a cliff. We can see this conversion in action at hydroelectric dams, where water held at a height converts its potential energy into kinetic energy. As the water flows down, it spins turbines, converting potential energy into kinetic energy, which is then used to generate electricity. This process is a powerful demonstration of energy transformation. Thermal energy is the energy that comes from heat. It is a form of kinetic energy due to the motion of particles within an object. Heat is the transfer of thermal energy from one object to another. This transfer can occur in various ways, affecting everything from the food we cook to the weather we experience. Thermal energy is related to the movement of atoms and molecules within an object. The more these particles move, the higher the thermal energy. The faster these particles move, the hotter the object is, and the more thermal energy it has. This is why boiling water and glowing metal are so hot. Thermal energy can be transferred in three ways: conduction, convection, and radiation. Each method has unique characteristics and applications. Conduction is the transfer of heat through direct contact. For example, when you touch a hot stove, heat is conducted from the stove to your hand. Convection is the transfer of heat through the movement of fluids, such as liquids and gases. This is why hot air balloons rise and why ocean currents circulate. And radiation is the transfer of heat through electromagnetic waves. This is how the sun's energy reaches the earth and how microwaves heat our food. Thermal energy is important in many different processes. It is essential for cooking, heating, and even generating electricity. For example, we use thermal energy to cook our food, heat our homes, and generate electricity. Without it, many modern conveniences would not be possible. Thermal energy plays a crucial role in weather patterns. It influences the formation of storms, winds, and other weather phenomena. As the sun's energy warms the Earth's surface and atmosphere, it drives the complex systems that create our weather. This warming effect leads to the movement of air and water, driving wind, rain, and other weather phenomena. Understanding thermal energy helps us better comprehend the world around us. Chemical energy is the energy that is stored in the bonds of molecules. This energy is released when chemical bonds are broken or formed. Chemical energy is essential for life. Plants store chemical energy in the form of glucose through photosynthesis. Animals get their chemical energy by eating plants or other animals. The food we eat contains chemical energy that our bodies use to move, grow, and function. Chemical energy is also used to power many of the technologies that we rely on. Fossil fuels, such as coal, oil, and natural gas, contain chemical energy that is released when they are burned. This energy is used to generate electricity, power vehicles, and heat homes. Radiant energy is the energy that travels in the form of waves. Electromagnetic radiation is another name for radiant energy. These waves can travel through space and matter. Light, radio waves, microwaves, and X-rays are all forms of radiant energy. The sun is the most important source of radiant energy for life on Earth. Sunlight provides the energy that plants need for photosynthesis. Sunlight also warms the Earth's surface and atmosphere, which drives our weather patterns. We use radiant energy in many different technologies. We use radio waves to transmit information wirelessly. Microwaves are used to heat food. X-rays are used to take pictures of the inside of our bodies. Energy is constantly being transformed from one form to another. These transformations are happening all around us all the time. For example, when you turn on a light switch, electrical energy is transformed into light energy and thermal energy. When you drive a car, the chemical energy stored in gasoline is transformed into kinetic energy, thermal energy, and sound energy. Energy transformations are essential for life and for many of the technologies that we rely on. Understanding energy transformations is essential for developing new technologies and for solving some of the world's most pressing problems. Energy conservation, a universal principle. The law of conservation of energy states that energy cannot be created or destroyed. It can only be transformed from one form to another. This means that the total amount of energy in the universe is constant. The law of conservation of energy is one of the most important laws in physics. It has many important implications for our understanding of the universe and for our everyday lives. One implication is that we need to conserve energy. If energy cannot be created, then we need to use it wisely and avoid wasting it. We can conserve energy by using less electricity, driving less, and recycling more. Another implication is that we need to find new sources of energy. As we deplete our reserves of fossil fuels, we need to find renewable sources of energy that can meet our growing energy needs. Nature is ultimate. Like, share, and subscribe.